Today we discuss on important topics related to splitting field. Okay, we now write this definition of this splitting field. Let K be a field. Okay, K be a field. A polynomial fx, a polynomial fx. Okay, in Kx is said to be split. Is said to be split over K. Okay, sorry, over a field is superset of K. Okay, if fx can be factored as a product of linear factors. Okay, product of linear factors in Sx. Okay, that means fx can be factored in Sx. Okay, then we write this one. That means this polynomial belonging to this Kx split over S. Okay, now a field a field S containing this K okay, is said to be a splitting field. A splitting field is said to be a splitting field for fx. Okay, for fx over K. If fx splits in S or over S, but over no proper subfield, of S extension of K. Okay, so this one is not a problem at all. That means a field is containing K is said to be a splitting field for fx over K if fx splits over S but over no proper subfield of X is extension of K. Okay, so we just know about this splitting field definition. Now we're going to be an example related to that topics. Okay, we know about that. See the field of complex number. Okay, this one is a splitting field. Of which polynomial? Of or for the polynomial x square plus 1, okay, over R. This polynomial, that means this polynomial over R obviously have a splitting field. This one be C. Now we that means elaborately discussion about that topics now. That means x square plus 1 factor into x plus I and x minus I multiplied of x minus I. Okay, we know about that fact. X square plus 1 equal to x plus I multiplied by x minus I. Okay, then what happened? That means these are in Cx. Okay, x plus I belongs to this Cx and obviously x minus I also. Okay, so what we obtain here, we obtain CR has no proper intermediate field. Okay, here C extension of R has no proper intermediate field. Okay, so why? Since index of R in C equal to 2. Okay, now we talk about that. That means if if some if some L belongs to this R and C, then what happened? Then L intermediate field of C extension R, then 2 equal to by this index of R upon C or of in C equal to this one C index L and L index R. Okay, and then this one happen what? That means this one one, but this one not possible. That means either this one and this one 2. Okay, so what happened? We erase lower portion. That means we write it in this way. So either any one be 1. Okay, otherwise this one can't multiply it. That means 2 multiplied 1 then 1. Okay, so this one means what? Either L equal to R or C equal to L. Okay, not a problem at all. So C is a splitting field. That means we obtain this one also. That means C extension of R has no proper intermediate field by using this index theorem. Index of R upon in C and index of L in C and index of R in L multiplied of this one equal to this and then this one equal to 2. That means any one 2 and other one is 1. So this one happen. Okay, so now we also see that two conditions are hold. That means this one are factored in Cx, this polynomial x square plus 1, and obviously no intermediate field is here. So C is okay, C is a splitting field. C is a splitting field. Splitting field. Okay, for the polynomial x square plus 1 often R. Okay, or over R. Now we erase this portion and going to discussion another portion about that problem. Okay, that means we see about that this splitting field. Okay, this C is not the splitting field of what? Of x square plus 1 over q. Okay, why in this way? Since since x plus I, okay, sorry, x square plus 1 splits over qi subset of C, okay, that means x square plus 1 also split over qi, okay, and so C is not splitting field of x square plus 1 same polynomial but over q, okay, here qi also, that means C present, and qi not equal to C, okay, qi obviously subset of C, okay. So also this polynomial split over qi, but that means this C is not splitting field of x square plus 1 polynomial over q, okay. That means here no that means one proper intermediate field we obtain, okay, this qi we obtain, that means q subset of this subset of C we obtain this one, where obviously this polynomial split, okay. So this C is not the splitting field of this polynomial over q, okay. So today we also discuss this splitting field and obviously related problem. I think all understand this portion properly. Now we're going to discussion about some theorem related to that portion, okay. So we write this statement of this theorem now, okay. We write the statement of this theorem here. Let K be a field, let K be a field, and fx be a polynomial in Kx, fx be a polynomial in Kx, okay, of degree n, of degree n, and let f extension of K be a field extension, be a field extension, and if fx equal to C of x difference c1, x difference c2 dot x difference cn, okay, in fx, okay. Then what happened? Then k of c1 c2 dot cn, okay, is a splitting field of for fx over k, okay. That means k be a field and fx be a polynomial in kx of degree n, then f extension of k be a field extension and fx equal to this one in fx, okay. Then k c1 c2 cn is a splitting field for fx over k, okay. Now we write the proof of this theorem, okay. We write proof now. C1, C2, Cn are the roots of fx. Okay, fx splits over this one k c1 c2 cn. Okay, now let L be an intermediate field of k c1 c2 cn. Okay, extension of k such that what fx splits over L. Okay, since kx is a UFD, okay, unique factorization domain, then there is only one way fx can split over L. Okay, and now fx equal to c multiplied by this one. Thus fx equal to this one. Thus c1 c2 this one cn belongs to this L. Thus L equal to c1 c2 cn. Okay, okay, now c1 c2 cn belongs to L, and this L subset of k c1 c2 superset of k c1 c2 cn. Hence this k c1 c2 cn is the smallest intermediate field over which fx is split. Okay, so k c1 c2 cn is the smallest intermediate field over which fx splits. Okay, so we also see that means if k be a field and fx be a polynomial of degree n, then if extension of K be a field extension and fx equal to, if fx equal to multiplied by C multiplied by x minus C1, x minus C2, x minus Cn in fx, then K C1, C2, Cn is a splitting field for fx over K. Okay, because this one is the smallest intermediate field over which fx split. Otherwise, that means any smallest intermediate field of extension of K and K C1, C2, Cn, K C1, C2, Cn extension of K, any other extension of K not contain this polynomial or not splits this polynomial properly. Okay, so this one happen, and so also that means obtain this one is the splitting field. Okay, so today I'll stop here. If you get this type of video, please subscribe and follow my channel and click on like options. Okay, thank you.